Welcome to this series of the EU's course interviews, where we talk with leaders in the energy transition. I'm Benjamin Lehner, CEO of the Dutch Marine Energy Center, and I'm here with Bernardo Silva, who is the assistant professor of University of Porto and the leader for the renewable energy and storage integration at INESC TEC. And I'm here at a marvelous place, but I actually don't know where I am exactly. So, hi Bernardo, and where am I?
And welcome to Porto, welcome to the high voltage laboratory from Faculty of Engineering and University of Porto. This is a place where we do a lot of tests regarding high voltage devices, how the devices behave with high voltage, and if they can withstand those high voltage. That can occur for...
High voltage is like where I charge my car, or?
This is 600 kilovolt generator, and over here we have 1200 kilovolt generator, pulse generator. So it's to try to model and to mimic high voltage coming from lightings or high voltage coming to maneuvers that happen on the grid. So we have very high voltage here.
And when we bring electricity to shore from our offshore installations like in EU's course, then we need this high voltage grid, or?
Yeah, not that high, but we do need to increase the voltage, so we reduce the current for the same power, and with this we reduce the size of the cable. But there is a challenge that comes with that. We need to have this big voltage within the cable, so insulation is important. Here we can also assess and test how the cable is able to withstand big overvoltages and set the limits for those cables.
Very nice. And in the EU's course project, we developed, or we were working on a T-connector. Can you, what has that to do with high voltage, and can you actually explain what is it actually?
Yeah, the T-connector is a splitting device that is intended to hybridize existing farms, because EU's course is a project related with hybridization of offshore energy. So let's suppose you have already a wind farm and you want to hybridize with wave energy. So the T-connector is a plug-and-play device that you use to interconnect a second farm into the existing.
So I'm plugging in my wave device into the wind park with this T-connector.
Yes, but there is no such thing in the market for those voltage levels, and the idea here was to assess some devices coming from the oil industry with bigger voltage levels, around 60 kilovolt, and to make some tests on those devices to check how they behave according to some standards. However, unfortunately, in the framework of the project, we were not able to have one device, a T-connector, delivered in time. So what we did was to test and assess it from simulation, from numerical simulation. But INESC TEC work didn't end there. We have done work related with how to hybridize a farm. How much of wind, how much of wave, how much of oceanic PV should we have depending on the resource, depending on the geography, and how should we combine this to increase the profitability of the farm. This was also a very interesting work that we did, not in this lab, it was in the simulation, but it was very fun.
So the grid work, really the hybridization work, and then I think there was also a robotic part to INESC TEC's package, basically, for the project.
From INESC TEC package, we also have our colleagues from the Center of Autonomous Robotic Systems, which are bringing autonomous robots to the surveillance of the farm. And when I say surveillance, it means that I want to monitor not only the farm assets, but also the environment that it exists close to the farm, to understand if we are provoking problems to some species that may have there, such as cetacean. And at the same time, since we are with the robots in the sea, we take the advantage to understand if everything is behaving as it should, or if it requires maintenance, or if we are having failures on some devices. So doing this with boats and human is very difficult, because we know how the sea is. We are close to the Atlantic. With robots, things come easier, reducing the cost, overall cost of those farms.
I see a lot of great contributions to the energy transition, to what we do. Is that also what brings you out of bed in the morning, or what is your personal drive?
Yeah, every day the first task that I do when I wake up is switch on the lights and check if they go on.
So far, so good?
So far, so good. We had one day, it was not in the morning, that we had some problems, but to achieve that we need to have generation, and we must not forget that we are increasing in the energy transition, we are increasing the electricity usage, not only in electrical mobility but also in industry, and we need to generate more affordable and sustainable electricity, and these are the factors that makes me waking up and coming with a smile to the work, because we need to face challenges that overcome from the integration of renewable.
Spoken like a real engineer, you're waking up to solve challenges, and this is amazing. And the EOS Course project has contributed, or you have contributed to the EOS Course project greatly in solving some of these challenges. The T-connector work will also, part of that what we did will be published as a public deliverable soon, so stay tuned for that. And with that, thanks a lot, Bernardo, for giving me these insights, giving me this tour. I'm a bit scared now that I don't know how many voltage are behind me, but I'm sure you won't turn it on. And thanks a lot for listening in.
Thank you.